Now the three equations we chose to solve are these three. Okay, these are the equations that I circled previously. These are the equations we're going to solve. So the first question I asked is, well, what variable would we want to eliminate among these three equations? And somebody very quickly, somebody hasn't even been in class when we started all this, said, well, eliminate C. A very good answer. That's fairly obvious, but it was good that somebody, just based on what they learned before they took this course, was able to answer that question. Okay, so C is going to be very easy to eliminate. All we would really have to do would be subtract one equation from another, and C would go away. Now usually I advocate that you would multiply one of the equations by -1 and then add them, because when you subtract, if you have negative numbers and you're subtracting them, it's easy to get confused and make mistakes. In this case, all the numbers are positive, so we're going to go ahead and just subtract. But usually I want you to use such multiples. Well, we'll see that in a minute, because we're going to do it down here. Okay, multiples that make one of the things positive, one of them negative, so they add up to 0, equal and opposite. Okay, if we subtract the first equation from the second, we're going to have 100a subtracted from 400a, giving us 300a. 10b subtracted from 20b, well, that gives us 10b. 138 subtracted from 83 is -55. Okay, so there's an equation. We've eliminated the variable c between these two equations. Now, we need to pick two different equations, okay, and eliminate c between them. So we've got a couple of choices. We could choose the first and the fourth equation, or the second and the third equation. And then we would be able to make our choice of which one we wanted to subtract from which. So we've actually got 4 choices to make here. Somebody said, okay, let's do these two. Okay, very good. And we're going to subtract the one with the smaller numbers from the one with the bigger numbers, because that's the thing that pretty much makes sense. Now, of course, the bigger numbers are in this equation here and here, but in this side, the number's bigger here, but that's not going to be a problem. Okay, 1600 minus 400 is 1200, so we've got 1200a. 40 minus 20 is 20, so we've got 20b. 40 minus 83 is -43. Now look what we've got. We've got 2 equations and 2 unknowns. And this is a topic that we pretty much nailed last week, and the homework I've seen looks very good on this. Of course, I haven't seen homework from most people. Hint, hint. It's your grade, Okay, so what do we do with these 2 equations? Well, we subtract. We don't subtract. We're going to first choose whether we want to eliminate A or B. Okay? And it would be easy to eliminate either. For example, we could eliminate A if we multiply this first equation all by -4. Because -4 times 300 is -1200, and then when we add the equations, the A's would go away. We'd be able to solve for B. Of course, then we'd have to multiply this by -4 to get -40. This would give us 220. So, this equation would be changed, but then adding the equations that result, the A's would go away. Now, when I asked the class which variable they wanted to choose, they weren't completely sure, but they said, you probably ought to go with B. And that's what I do. The numbers are smaller, although that's not a big problem. Okay, in this case, because to eliminate A, you just multiply by -4. That's not a huge number. Okay, well, in any case, to eliminate B, we're going to multiply the first equation by -2. And then we're going to have -20b and 20b, and the b's are going to go away. We're going to be able to solve for A. Very easy. So we do that. If I multiply this equation by -2, I get this equation. In any case, that's not clear. -2 times 300a is -600a. -2 times 10b is -20b. And -2 times 55 is 110. We add that to the second equation, and we just write down the second equation. So I've written it down. I said the first equation multiplied by -2, and that's what I've got here. Here's the second equation. Then I add them, and of course the b's will go away. The a's will add up to 600. 1200 and -600 is 600. And 110 and -43 is 67. So 600A equals 67, so A equals 67 over 600. Now, one student worked this out with the fractions, and another student worked it out with a decimal approximation. They got slightly different results when they solved the two equations. But remember that we got some uncertainty in the data anyway, and that might or might not make a big difference depending on how many significant figures you use if you approximate this, okay? But it turns out that this one's easy to do with the fractions, okay? So I went ahead and used the fractions because some students were doing that, and we need to keep talking about fractions because our schools and our prerequisite courses don't do a good job with fractions. And people bypass fractions by using calculators. So, okay, well anyhow, so A is 67 over 600. What are we going to do with that? Okay, let's try to follow the blue arrow, and I said it's premature getting up here. It is. Okay, but there's a orange arrow. Take me up here. Okay, we're going to substitute A into one of these two equations. Now, I chose not to substitute A into this equation because in the process of getting A, I changed this equation by multiplying it by -2. Okay? And that could affect our solution if I made a mistake. Okay? So I'm going to plug this value of A into this equation because it's a little more appropriate to do that because I've already messed with this one. I didn't mess with this one until I added it to what I had here. Okay, so 67 over 100 in for A. This equation very clearly becomes this equation. There's the 1200. A is 67 600ths. And then we got the 20B and the -43. Well, it's convenient because 600 goes into 1200 twice, and that gets multiplied by 67 to give us 134. And then we got our 20B and our -43, and this is all becomes extraordinarily easy to solve, and we get B equals -177 over 20. So we've got values for A and B. How are we going to get a value for C? Well, we got a good answer from the group. Said, well, you just take A and B and plug it into one of the other equations, okay? Now some people tried to plug the values of A and B into one of these equations. Well, that's actually kind of a good thing to do, especially if you use, well, it doesn't matter which one in this case, because it serves as a check. You're going to get the same result if you correctly solve for A and B, okay? But it doesn't help you find C. Okay, it's a good thing to do because it's always important to check. But to find C, you'd better substitute your values of A and B into an equation that has a C in it, which would be any one of these three. Okay, so plugging our values of A and B into the first equation, just because I could get the arrows up there, you see, I said, okay, we take the value of A and we follow the blue arrow and plug it in here. We take the value of B, follow this blue arrow, we plug it in here, and we get an equation that I wrote down here. And I could have done a better job of writing it down, but it should be legible on camera. 100A becomes 100 times what? 67 over 600, right? And 10B becomes 10 times, well, -177 over 20. And that is plus C equals 138. Well, these fractional expressions simplify quite a bit. 100 goes into 606 times, so you're going to have 67 over 6. 10 goes into 20 twice, so you're going to have -177 over 2. And plus C equals 138. And then we can add 177 over 2 to both sides, and this thing will go away. We'll have 177 over 2 here. We can subtract 67 over 6 then from both sides, and we'll get a -67 over 6, and then we've got C sitting here all by itself happily, and here's our solution. Okay. Of course, we want to express this as a single number or a single fraction. If I want to express it as a fraction, I put everything over common denominator 6. And I might have done that correctly, okay? I give myself about a 50-50 chance of getting all of it correctly. Okay, here are the three numbers expressed with common denominator of 6, so I can add the three numbers, and I get this. And I was thinking that's 219 and a third, okay, 200, and then you go into, yeah, I still get 219 and a third. Somebody got 215 and a third using a calculator, and somebody pretty reliable, so I still have a question whether I got that correct or not. You can work it out yourself. Okay? Well, that's what led us to these values that I quoted earlier. I said, we solved these equations, we got these values, now you've seen it. And we've already seen how these three values give us this equation, which is exact, but there's no real point in being exact in this case, because our times aren't observed exactly. And these measurements, they're close. They're probably within a millimeter of the right measurement, and these are in millimeters, but there's still a plus or minus on the data, so it doesn't hurt to express these numbers. For the uncertainties in these data, 3 significant figures is more than enough.